Alrighty, two more problems here from page 176, number 35 and 37. And the instructions say to simplify the expression. So we're just simplifying here. Both of these are addition problems, addition or subtraction problems, and both of these problems need us to make sure that we have like terms before we add or subtract the coefficients. So I'm looking for like terms. And for my expression to have like terms, each of those terms have to have the same base, so same base, and the same powers or exponents. If they don't have these things, the same base and the same exponent, then I'm going to try to do some other things. Maybe I can break things down, maybe I can rewrite. There may be some tricks to rewriting the expression in some way so that each term has the same base and the same exponents. All right, let's look at number 35 first. So number 35 says 1/8, so this guy right here, 1/8 times the 4th root of 7 plus 3/8 times the 4th root of 7. And in this problem, my base is this part right here, the 4th root of 7, and they both have 4th roots of 7, or actually the 7 is the base, and the exponent is right here. It's written as a root, but they're the same, definitely the same exponent. I could write this as 7 to the 1/4 power. Might be a little easier to see that the 7 is the base. So here's my base. Here's my base. And the 1/4 is my exponent. All right, so I definitely have like terms. I've got the same base, it's 7, and the same exponents, 1/4. Once I have like terms, then all I need to do is to add the coefficients, add or subtract, right, depending on the sign. Add or subtract the coefficients. And I just want to remember that the base, base, there we go, base and the exponents stay the same. They don't change. Stay the same. I'm not going to touch them. So all I need to do now is to add or subtract my coefficients. So in this case, my coefficients are the 1/8 and the 3/8. So it's these guys right here, the 1/8 and the 3/8. So let's consider this problem here. Let me get rid of my 37 for a minute. I am adding 1/8 plus 3/8. All right, if I'm adding a fraction, I need to have a common denominator, which I do, it's 8. And then all I need to do is to add the numerators. So 1 plus 3 is 4. And of course, the denominator doesn't change. It stays 8. I think I can reduce this. 4/8 would become 1/4. All right, so 1/4 what? Well, 1/4 4th root of 7. So it's really 1/8 times the 4th root of 7 plus 3/8 times the 4th root of 7, which is 1/4 times the 4th root of 7. And I know I'm done. I know I'm done because I cannot get a group of 4 of anything out of that 7. So that's my answer. Yay! All right, let's take a look at the next one, number 37. Number 37 is still going to have me go through that same process. I need to have some like terms, which means I need to check for the same base and the same exponent. And once I have like terms, then I can add or subtract the coefficients. So number 37 has -6 times the 7th root of 2 plus 2 times the 7th root of 256. All right, let's do our like term check. Do I have the same base? No, I do not have the same base. Look, I've got a 2 here, and I've got a 256 over here. So that's not going to do me any good. I'll have to do something about that. Let's just double check the exponents. So the exponents are up here. So I've got a 1/7 and another 1/7. So the exponents are okay. This part's okay. This part here, the same base, I'm going to have to do something about. And how we rewrite roots is by breaking them down. And I think that's what I'm going to try to do with this 7th root of 256. Let me just do a little side work over here. Side work, and see if we can rewrite the 7th root of 256 as something else. All right, 7th root, that means I'm looking for groups of 7 factors. So I'm looking for a group of numbers that are all the same. When you multiply them together, you get 256. All right, well, let's just start breaking down 256 here. We'll pull out a calculator. Usually 2 is a pretty great number to divide into something even, so let's try 256. Oops. 256 divided by 2. And what does that give us? That gives us 128. All right, so I've got 2 and 128. Now let's keep going. We don't have any even pairs right now, let alone a group of 7 identical factors. 128 will split up into 2 and 64. Okay, this is looking promising. I've got 2 2s. What can I get out of 64? Well, 2 and 32. I'm up to 3 2s now. 32 would be 2 and 16. 4 2s is looking very good. 16 is 2 and 8. So now I've got 1, 2, 3, 4, 5 2s. 8 becomes 2 and 4, 6 2s. And 4 becomes another 2 and 2. And there's my group of 7 2s. Here they are. 1, 2, 3, 4, 5, 6, 7 2s. With 1 2 left over. All right, let's rewrite that 256. So the 7th root of 256 is going to be 2 times the 7th root of 2. So this 2 here comes from this group of 7 2s. I've got one group of 7 2s. This 2 here comes from the 1 2 that is not grouped with anybody else, one that was left over when I found my group of 7 2s. Okay, I need to be careful that I don't lose anything though from the top row. I still have this 2, so let me bring down that 2. And let's rewrite the right-hand factor. So 2 times 2 is 4 times the 7th root of 2, and bring down the first factor, the one on the left-hand side. 6 times the 7th root of 2. All right, now let's do our like term check. Do I have the same base? Yes, they're both 2s. Do I have the same exponent? Yes, they're both 1/7. That means that I can add or subtract my coefficients. So -6 plus 4 is going to be -2. -2 times the 7th root of 2. And there's the answer to number 37.